So for today's lesson, we're going to talk about experimental and theoretical probabilities, and we're going to use that to kind of make sense of what the heck's happening in the real world compared to what's happening when we use math to come up with an idea of what's going to happen in the real world. Okay? So we need to complete these tables. Now, we don't really have the chance to do that, but I'm going to help you through it. So we're going to be talking about a six-sided die, right? We're going to be talking about what happens when we have one or two dice rolling. Okay, so imagine I have a die, okay, and I am I'm taking my one die and I'm rolling it. What's the probability of getting a 1? It's 1 out of 6, isn't it? And the same can be said for 2, and so on. So for a simple-sided die, basically, we know that the probability of getting one of the sides is always 1/6. Now, the probability of a decimal, the probability as a decimal comes out to be this. 1 divided by 6 is this 0.166 repeating, okay? Now, remember that beautiful chart that we had before? Let's just zoom out and move this over, and we'll quickly create our chart. Now, here's the rule. Imagine you have 2 die, and you have to figure out the possibility of getting a 2, a 3, a 4, a 5, a 6, or whatever. So what we'll have to do is we'll have to create a probability sum table for 2 dice. And now that we have our probability sum table for 2 dice, this allows us to figure out how many times we can get a 2. And if I look here, there's only one possibility of getting a 2. And in fact, there's 36 spots, so we're going to write this as 1 over 36. Now, if we look at the 12, a total of 12, we also have 1 over 36. So we're going to cut down on the amount of work that we got here. So the next thing I want you to do is I want you to immediately take a moment and calculate what 1 over 36 is on your calculator. And you're going to find that 1 out of 36 is 0.277. 0.0277 ... and it goes on forever. So now let's do the same thing for 3 and 4 and 5 and 6 and 7. So pause the video and then check to see if you're right for each of the fractions, and then I'll provide the decimals. So for 3, for a sum of 3, we get 2 out of 36. And for the sum of 11, we also get 2 out of 36. And that decimal that we have here is 0.0555. It goes on forever. And the same will happen for number 11. Now let's figure out what we have for a total of 4. So a total of 4 is 1, 2, 3 spots. So it's 3 out of 36. So we have 3 out of 36 also for 10 because there's only 3 spots for 10 on this chart. Remember that this part here is die 1 and this part here is die 2, and it's the combination that makes these, the total on the die that makes these numbers. So we have 0.8, 0.0833 for both of these. Now let's do the same for 5 through 9. So 5 and 9, 4 out of 36. And we have these 0.1388. And our final answer for 7 is 6 out of 36. And that's because there are, you guessed it, 6 possibilities for the number 7 to come up. And now we'll just move our probability dice table onto our sheet here. And you'll see that on our table that we have here, we're going from 2 through 12 here. Those numbers show us that the highest probability is happening right there, right in the center. That is our highest, our most probable number. It's our most probable number that will always come up, and for that number, the decimal is 0.1666, repeating. And that's why when you play something like Settlers of Catan, the number 7 comes up over and over and over and absolutely destroys everyone. Now, just a quick reminder that when we talk about this probability sum table, this represents the sides of dice 2. Let's say dice number 2. It could be dice number 2, and then this could be the sides of dice 1. It could be dice number 1 or dice number 2, where dice number 1 is on the bottom and dice number 2 is on the side. It doesn't matter. This dice table helped us make sense of our probability distribution table of the probability table for our rolling dice. Okay? All right, so now let's move on to this. For example, 2. Right? What I'd like you to do is I'd like you to take a look at this this website, enrichmaths.org 717. And what I want you to do is I want you to try to calculate the experimental probabilities of an imaginary dice. The die, when you click on the screen, it automatically rolls the die. And all I want you to do is keep track of each of the events as a tally. And I want you to tell me how many 2s come up, how many 3s come up, how many 4s come up. And also, when you're doing it, keep track of all of that, whether it's be 1 die or 2, right? And keep track of the number of times that you rolled, right? So remember, it's enrichmaths.org/717. And what I want you to do is I want you to use the second page of this this worksheet that I have, and keep track of the number of trials that we have. Now, I'm going to tell you how many trials that I want you to do, okay? For single die and rolling 2 dice at once. So on the second sheet, what I'd like you to do is I would like you to do a total of 30 trials for the tally sheet that I've given you as part of this assignment. It's actually going to be on the website, and all you're going to do is anytime you hit the button to kind of make the die roll, just keep track whether it's a 1, 2, 3, 4, 5, or 6, or a 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12, and just keep tally. So 1, 2, 3, 4, 5, and then maybe 1, 2, 3, maybe you got 3, and then you'll know how many, you total up your tallies to find out how many you have, and then you can figure out your frequency, which is the number that we get in the tally. In this case, my tally is 5, and in this case, for an event of 2, an event where I see a 2 on the die, I'm going to say there's an event of 3. Now, if I was looking for the probability as a fraction, I would write this as 5 over 8, and then this one would have been 3 over 8, and then our calculations would be our probability calculations as a decimal would be up to 4 decimal places. All right, so use the 4 decimal places to give me those numbers. Okay, all right, that's it. The sheet's up and running, and then when you're done working on those sheets, we'll take a look at, I want you to continue with this video because I have one more thing to say as the result of what's actually happening here. So just pause the video and then take a look. So the result is, as we increase the number of real-world experimentations on the one topic, what happens is that experimental probability ends up getting closer and closer to what the theoretical one is, i.e. the math version type one that we came up with, where we had like a model, a picture of what all the possibilities were. That picture of possibilities, the percentages that we come out with, end up being approached by the experimental probability. Okay, so let's talk about today's lesson. Example 3. During the month of April, at least some rainfall was recorded on 12 different days at the Sarnia Airport weather station. Now, here's the deal. In April, there are 30 days. 30 days half September, April, June, November, all the rest have 31. Yep, 30. So there's 30 days here. Okay. Now, the fact that we have 30 days gives us an idea of how we can figure out something as simple as this. So we're talking about rainfall here. What they're just asking us right now is, suppose that one day in April is selected at random. What's the probability of choosing a day that it rained? In order to do that, we would literally just write, well, the probability of rain is what we want, which it said there were 12 different days. So we're going to go 12 divided by the total number of days in April, which is 30. Okay? So remember, this is the days in April. And then this is the rained days. So what we want over the total. And then we're going to go and reduce this by dividing both the top and bottom by 6 to get our final result to be 2 over 5. Okay? And it says, what's the probability of it raining? It's 2 over the 5. So you'd say probability is 2 over 5, and we're done. Or you could write, or 40%. 2 divided by 5, and then multiplied by that. All right? So now, let's take a look at this next problem. How could you make a spinner to simulate what was happening in part A? All right? So the rule is you're going to sit there and you're going to figure out what the probability of rain is. So we know the probability of rain is 2 over 5, right? And we found that to be 0.4 when we divided, which gave us 40%, right? And then we also have the probability of not rain. If the probability of not rain is just whatever's left over, which is 3 out of the 5, which is 0.6, which is 60%, right? Now, if I have a spinner, here is the rule. A spinner has 360 degrees in it, right? Okay. I.e. there's 360 degrees in a circle. Now, because of that, I'm going to take 40% of 360 to figure out what angle I have to do. So now 40% is 0.4 because we know what that is. We're going to times that by 360, and we're going to get 144 degrees. And then for 60 degrees, sorry, 60%. We're going to go 60% of 360, which is going to be 0.6 times 360, which is going to give us 216 degrees. So each of these wedges on my thing are going to be 216 degrees here and 144 degrees for this wedge. That's it. That's how we do it. Okay. Now let's skip C because we don't have time to do that. All right. So now suppose a couple were to have 3 children and we want to determine the theoretical possibility of getting girls and 1 boy. Now, what we're going to do is we're going to take a moment and we're going to figure out how many possibilities we could possibly have for boys and girls, right? So the rule is this. There's 2 choices, right? So there's 2 choices, boy and girl. The choice is boy and girl. So let's figure out how many possibilities we have. So in order to do this, the number of choices is equal to, well, in one spot we have a boy and a girl, which is 2 possibilities. And we have another boy or a girl, which is 2 possibilities. And we also have another boy and a girl, which gives us a total of 8 ways. So now let's go through all the possibilities. So imagine the couple decides to have a boy or a girl and 3 of them. So imagine there are 3 boys. A second possibility could have been a girl change the first boy into a girl and then have boy and boy. Now we take our girl and move the girl instead of being the first person, the girl becomes the second person. And then similarly, the last position is where our girl is. So now this part represents 1 girl. So now your next thing should be, imagine if we were looking to have 1 boy. So if we had 1 boy, there would be this. So we got a boy and 2 girls. Boy is in the first position, then a girl, a boy, and then a girl. And then we have 2 girls first, and then we have a boy last. And then the last possibility would be all girls, no boys. So this one here is 1 boy, or you could think of it as 2 girls. And then finally, 3 girls. And then this one, I guess, would be 0 girls. How many ways you could get it. And that is how you would figure out what you were looking for. So now, in this problem, they said they were looking for 2 girls. So where do we have 2 girls in our list? We have 2 girls. We have 2 girls in 5, 6, and 7, right? And we have 1 boy, okay? And we can find our probability of this, determine the theoretical probability. The probability of 2 girls and 1 boy is literally just going to be 3 out of 8. We're done. So when you do this type of problem, you can figure it out by setting up a pattern that shows all the possibilities, or you can figure out all the different ways and then try to figure out how many ways you could get 2 girls and 1 boy. Now, this next problem says determine the theoretical probability of having at least 1 girl. What does that really mean? When it says at least 1 girl, we're talking about 1 or 2 or 3 girls, right? So imagine I was looking to find the probability of 1 girl based on what we knew from before. The probability of 1 girl we found to be 3/8. The probability of 2 girls is equal to 3/8. And the probability of 3 girls is 1/8, right? And literally, when we want to find the combination of these, we just add them up. So the probability of 1 girl or 2 girls or 3 girls is going to equal just 3/8 plus 3/8 plus 1/8, which is equal to 7/8. And that is our answer. Now, another way of doing this would be finding the probability of no girls, which is 1/8. We call this the indirect method. And the probability of at least 1 girl is going to be 8 minus 1/8, which gives us 7/8, and we're done. Yeah, so this one here on the right is called the direct approach, where we break it down into 1, 2, or 3 girls. This other one says there are no girls, right? What's the probability of that happening? 1. What's the probability of having at least 1 girl? 1 minus 8, or 8 minus 1. All right, and now I do believe your homework is set to be page 82, number 2, 3, 4, and 5. Question 6 is tricky, so if you don't get it, don't worry about it. But you need to be able to do number 8 and 12, and 13 is a pretty good question. When I say it's a good question, you can assume that might show up on a quiz.